So the recording is in progress and I hope you can see my screen. Raise your hand or give me something. So yeah, all right, thumbs up. Also, what I like to point out is if you have any kind of communication, please go through the live event channel in the Unreal community in the Incus Unreal Circle. So I have it open over here on the other side. So whatever you type, you say, it doesn't get lost in this Zoom call. We deactivated the Zoom chat. So whatever is happening on the Zoom, it will be lost after this thing over here. So that's why we are going all in with the Discord, because that is our archive, you could say. So even after this this session here in Zoom, we still have everything in the chat in Discord. So that's why we're going full Discord over here. So this learning nugget today is all about blueprinting, meaning visual scripting in the Unreal Engine. And as I said, this is designed for beginners. But first things first, who am I? My name is Robin Hasenbach. I'm from the Cologne-Bonn region in Germany. I've been using Unreal Engine since 2014, 2015. Before that, I was for 10 years using Unity and also doing some other things as hobby. So in a professional way, you're using Unreal Engine for now 6 to 7 years, something like that. I'm also mostly a programmer. So my background is C++ and blueprints and some tech art and so on, but mostly programming. And I'm an Unreal authorized instructor and also an XR enthusiast. So all about virtual reality, augmented reality, and so on. But also a lot more to put into one single slide. And I don't want to talk that much about myself. So I will just go on. What I expect you to bring to this session is you should have at least worked a little bit with Unreal Engine. I don't expect you to be all day and night working with Unreal Engine. I know that Volker is doing that, but still, I don't expect you to have this on the table. I just want you to be familiar with the general UI and navigation of Unreal Engine, because otherwise you may get lost in this. Also, of course, I expect you to be interested in learning about blueprints. Otherwise, you wouldn't be here. So I think that's already off the hook. And if you want to, in any case, follow along or later try out what we were doing over here in this Learning Nugget, I'm using the Unreal Engine 5.1.1 for this. I know there's already the Unreal Engine 5.2 preview out there. We're not going to use that, as it's not bringing any like real new features to blueprints that interests us for the moment. So we stick with the stable 5.1 for the moment. Who is this for? Beginners. As I said, you don't need to be a programmer to be in here. Also, this is not for game developers only, as visual scripting and blueprints is a cross-disciplinary feature, and it doesn't matter for what kind of project you're using this. It will always, the basics we talk about today, they will always be the same. It doesn't matter what you're doing. And also, even if you're already using blueprints in your everyday work, so you're a blueprint expert, you may still take a few valuable things today from this course. So even if you're already familiar with this stuff, this could be interesting for you. What you can expect, that we will take a look at the basics of blueprinting, and I will demonstrate the learned topics that we go through today, and you will get a handful of helpful info and trivia on blueprinting. What you, however, shouldn't expect is that after this learning nugget, you can just program anything you like, because we will just cover basics, and they are necessary, but they are just the beginning, the first step. Also, we will not cover all the basics, because that would still be multiple weeks of training, very intensive training to go through everything. So we will just boil it down to the relevant basics of blueprinting that most people, or basically everyone, needs to start blueprinting. And also, I will not create a full project. We will not do a AAA game, sorry. I will just do some demonstrations These are small snippets, you could say. So yeah, just to do some management expectation of this learning nugget, you could say. First, we will do some theory. I will mix it up with some demonstration. And in the end, we will do some questions and answers. As I said, all the communication goes through the Incus Unreal Circle live event channel. So please, if you have anything to write it over there. In the end, the learning outcome for you guys will be that you can name and recognize blueprint visual scripting terminology, that you can recall necessary methodology of blueprinting, that you can apply this knowledge by creating your blueprints, and you're able to go on your own and discover more about blueprinting after this learning nugget. So first things first, project setup. When you're creating your project, there are a few things you should know about when it comes to blueprinting and programming and so on. So when you set up a project, there is this little window on the side that lets you select Blueprint or C++. When you go with a Blueprint project, it is the so-called Blueprint-only project. When you also type C or select C++, you go with a C++ and Blueprint project. That means when you go with Blueprint only, you only have access to blueprints. And when you go with a C++ and Blueprint, you have access to both because they are designed to be worked with hand in hand. A Blueprint-only project can easily be converted to a both supporting project by adding some C++ code and the necessary modules and so on to your project. A C++ project can also be converted back to a Blueprint-only project, but that is way more hard. You would need to, by hand, remove all the C++ code and do some manipulations on some config files and so on. So it is in theory possible. In practice, it can be quite hard. So what I do, and I'm just doing this over here on the side now, I've already got Unreal Engine open. I'm going to create a games third-person template blueprint project. In my case, I call it Learning Nugget BP. You can call it whatever you like. As I said, you don't necessarily need to follow along. It's totally fine to just listen to what I say. But if you want to follow along, like Justin asked in the beginning, you can also go and go along. So programming and scripting. Two terms often used very interchangeably in game dev language. What's the difference? And the main difference is that a script is interpreted at runtime as where a program is compiled. That means a script is just a bunch of code as long as it stays in your project. And the moment you need it, it is executed and interpreted on the fly. A compiled program is already linked, static upfront, which brings some advantages, but also a lot of disadvantages. We'll go with it through the next bullet points. As I said, script very flexible, changes can be done easily, and a program needs to require recompiling. Scripting is often more accessible. So a scripting language is trimming away everything that you don't need, and everything you don't need. And a programming language requires a deep knowledge about programming in different kind of programming languages, whatever you're currently handling and doing. Scripting is handling errors for you. So in a scripting language or a scripting environment, it's quite hard to actually result in a crash. It can be done depending on how safe or unsafe some parts of Unreal Engine are. And a program, for example, a C++ program in Unreal Engine can, if it's buggy or broken, crash your application easily. So you, as a programmer, need to be aware of what you're doing so it doesn't crash. With a blueprint, it's quite hard to actually result in a crash. A script is often limited in its functionality as it only can do things that are exposed to that scripting language. In Blueprint, for example, you have access to certain features, but certain features are by design or even just because nobody thought about that, exposed to Blueprint. So it really comes down to what you're doing. For everything, there's a way around that. For everything, there's some plugin or something that you can still use to get your blueprints to do things it didn't do before. Yeah. A program, however, has got the full functionality of, for example, the Unreal Engine or whatever tool you're currently working with. So this is more general what I'm currently saying. This is not about Unreal necessarily, but still I'm relying this to Unreal. And in general terms, a script has got low performance compared to a program which has got high performance. Let's see how this behaves in Unreal Engine or in a game engine in general. So in Unreal, for programming, we've got C++. And for scripting code, we've got Blueprint. Automation, we've got Python and Blueprint. Materials, for that, we've got Material Graph, which is based on Blueprint. For VFX, we've got Niagara, which is based on Blueprint. For animations, we've got the Control Rig, which is, again, based on Blueprint. For procedural content generation, you guessed right, PCG is based on Blueprint. For data prep, we're using data prep recipes, which, again, are based on Blueprint. And I could go on and on and on. So even if you're not a programmer, Blueprint is super important for you, as it's the base for all the scripting in Unreal Engine, except Python, but that can even also be done with blueprints and combined. So yeah, from whatever you're doing, there's no way around blueprints in Unreal Engine. Quickly, I don't want to cover this too much, but in other game engines, it's a similar setup. In Unity, for example, you've got programming in C++ and C#, but the C++ part isn't publicly available, and it's hidden behind a very expensive license. So mostly in Unity, you're just doing scripting through C#. CryEngine, similar. You do programming in C++ and scripting in C# and schematic. So even in other tools, similar game engines and so on, it's all structured the same way. Programming in a high-level programming language and scripting in some other, really whatever you need for that tool scripting language. In Unreal Engine, that's Blueprint. So yeah, we are talking about blueprints today. I see the Discord always on the side. Okay, so the first thing we need to discuss is a bit of terminology. We need to discuss blueprint and blueprint classes, as this term is often used very mixed up. I goofed there. Give me a second. Why is this not showing up? Oh, because why did I do that? I'm so dumb. Give me a second. There we go. Yeah, live debugging of PowerPoint slides. Who doesn't love that? All right. So let's talk about blueprint and blueprint classes. Two terms, two more or less completely different things. Blueprint is the visual scripting language by Epic Games. It's used in Unreal Engine. It's coming from Unreal Engine. And to give you a bit of trivia there, actually Blueprint is called Kismet. In Unreal Engine 3, they came up with a basic trigger input-output system. You see the player is walking through an invisible wall, triggering a trap or a door or something, opening and closing, I don't know, something like that. That system actually was called Kismet. And Kismet scripts were always based in a level, and they were really basic. You couldn't do a lot with them, but that was the foundation for between Unreal Engine 3 to Unreal Engine 4 for Blueprint. as internally, actually, Blueprint is called K2 or Kismet 2. So Blueprint is just a fancy name for it. Internally, you will, in the source code itself, you will find nearly nothing about blueprints. It's all Kismet 2 or K2. Blueprint, in fact, is not bound to Unreal Engine. It's an open source system you could grab out of Unreal Engine and put into a completely different environment. So, for example, I've seen some experiments of it being used for app development. So not Unreal Engine, but completely separate from that, of cloud functionality, so stuff happening in the Microsoft Azure cloud, and even factory robot programming. So, you know, all of these nice factory robots, they could be programmed in Blueprint as well. So there are some experiments to get Blueprint in different environments, but none of them, as far as I know, are finished yet. In Blueprint, at least in the Unreal Engine, a Blueprint script is always embedded into other elements. That means that a Blueprint never can be on its own. It needs to be embedded into another object, another class of some kind. And also, from a technical side, Blueprints are always running in a virtual machine. So in the background of your Unreal Engine, it is always spinning up a virtual machine, which is just executing your Blueprint scripts. That first sounds like a really weird solution, but I will explain later why that is and that it's actually a really good thing. So now we've covered Blueprint. What about Blueprint classes? Blueprint classes are object-oriented programming. And there it is again, programming, that term. And actually, this is where the lines blur between a scripting language and a programming language. Blueprint is not a programming language, but it is pretty close to becoming one, or integrating into one. Blueprint classes are Unreal Engine specific. So this would be something that you could not grab out of Unreal Engine and put it into some other environment. It is only available and doable and thinkable in Unreal Engine. In the end, your Blueprint classes and your Blueprint scripts are calling C++ functionality. So your Blueprint code is in the end, in its virtual machine, just doing C++ without you knowing it. And to help you understand the term class, in object-oriented programming, you say a class and an object, as where a class in layman's terms is a template, and an instance of that template is one of these objects. So you've got classes and objects, basically the raw template and an instance of that template based on the template. As I said, we most likely need to embed our Blueprint into something else. And as Blueprint is based on Kismet, and Kismet was always running in a level, why not also go with a level Blueprint and embed some Blueprint logic into the level itself? We can access the level Blueprint from the toolbar, Open Level Blueprint, and anything we do there will only ever happen in this level. Let me open this up for you. So as I said, we're also doing this in a kind of demonstration way. This is the third-person template. I think most of you are familiar with that. You maybe have played around with it a bit. And in that third-person template, we've got this third-person map. When I now go to the Blueprint panel up here to the bottom, and I can say Open Level Blueprint, a new window is opening up. As with all windows and all of these subtools in Unreal Engine, I suggest that we take this up here and, like in a web browser, attach it to the side so we can, like tabs in a web browser, cycle through them. So what I have over here, that is a Blueprint editor, in this case for the, as it says down here, level Blueprint. And with that, we are already on to the next thing, blueprint graphs. When we are doing blueprints, when we are scripting these, we need to place them somewhere. So that is a blueprint graph, the place the scripts are living in. And you can even create multiple of these blueprint graphs to have multiple folders. Did I do that again? No, actually it's right. I wanted to show this over here. That's fine. So what I've got over here on the top left side is the My Blueprint panel. And there I've got currently one graph called event graph. The event graph is pre-existing for us. So whatever we are creating, it already is in there. I can navigate this event graph by holding down the right mouse button so I can navigate around, and holding down the left mouse button will create a selection rectangle. I know there are more features than that, and we will go through them step by step. So don't worry about that. Let's talk about blueprinting on its own. So the act of visual scripting in Unreal Engine. And the most basic thing to do or to know about when it comes to blueprinting are events. Events are these red nodes over here, as you see. So somebody's asking a question, how I got this window over here. I just went over here to the toolbar, open level blueprint. There we go. There you have it open. Back to the slide. All right. So events are supposed to be our starting points or triggers. This is where something starts to go on. This is this is a trigger. It will all make more sense when we're actually using these. Blueprint is read from left to right. And as these are starting points, it would not make any sense to have something on the left side of an event node. That's why everything interesting is happening on the right side of these nodes. So we've got an execution pin, and optionally, we've got parameters. The execution pin, only one of them is ever attached or available on an event, is starting the execution of the following nodes. Basically, we are designing the node by node order or step by step order in which these nodes should be executed. And this execution pin on an event is where it all starts. Parameters, they are optional, but the number of parameters can vary by event. So there are events having no parameters, and there are events having a lot of parameters. It really comes down to what event you're dealing with. Also, on the top right side, there's something called a delegate. That's a more advanced topic. We will take a look at that later in this Learning Nugget. But for the moment, just keep in mind there is this delegate, and you can do something with it, but for the moment, we don't care. There are some already existing, or sometimes also referred to as pre-existing events. The events that are pre-existing are created in a parent class. What does that mean? And that comes down to a principle of object-oriented programming called inheritance. Inheritance is one of the major parts of object-oriented programming. In inheritance, you've got these classes. You remember from a slide earlier, templates. And these classes, they come with properties, functions, components, all of these things. These could be variables, talk about them soon, other functions, events, and so on. And inheritance is basing new classes, new templates, on these existing ones. And that's something you always need to do in object-oriented programming. You always base your class on another class, extending it in that way. So you can create a chain of inheritance. To give you a sample, you've got object, you base on object vehicle, you base on vehicle truck, and you base on truck your specific model of truck that you want to drive around through your scene. And in that chain of inheritance from any object, you're getting more closer and closer and more detailed onto what your truck can do. Bringing properties with it, like what wheels you have, how big, how many wheels you have, that this can actually move in the scene. Maybe then in the truck, it starts to have a function for braking and for accelerating and so on. So you're doing that chain of inheritance. And even our level blueprint is doing this. As I said, blueprint classes based on object-oriented programming, we are never going away from that principle. Everything in blueprint classes is using inheritance. So also our level blueprint. Actually, the level blueprint is based on something called level script actor, which is always hidden but living in any level that you're doing. So even if you don't see it in a world outline or something, it is always available. And that level blueprint or level script actor is having a few pre-existing events. You can access this list of pre-existing events over here in the blueprint graph by going to functions, override, and there you go. This is a list of pre-existing events. And it even says where these events are defined. So for example, these ones are defined in actor, but this specific one, level reset, and that one, world origin location changed, they are coming from that inherited subclass level script actor, where we are now basing our third person map script on. So we are always going with inheritance. Besides that, there also is a system of custom events. I forgot this slide over here. Sorry for that. There are also some popular samples of pre-existing events. And the most popular ones are begin play. This is called on begin of the life cycle of this specific actor, so this specific object that we're dealing with. There's also tick. Tick is during the life cycle happening every X milliseconds, where X is changeable, of course. And the default means it is happening every 0 milliseconds, meaning every frame calculation, every time it is available. So per default, tick is happening once per frame calculation, but you could change this if you like to only do tick every, let's say, 200 milliseconds, 500 milliseconds, or something else. And then there's also end play, which is happening on the end of the life cycle of a single object, of a single actor in the scene. These are just the most popular ones. Let me show you some of these. Over here in my third person map level blueprint, I'm going over here to the side to functions. I'm going with begin play. And I got this begin play event over here. I can also go with this tick I just mentioned. I can move them around by clicking on them. I can also zoom in and zoom out using the scroll wheel. I can even zoom in more than that by holding down the control key while scrolling. So I can even scroll in more than that. So these are pre-existing events. Besides pre-existing events, there also are custom events. You can add custom events at any place, any time in your blueprint graphs, and you can design them to be whatever you need them to be. For that, you also have got input parameters. They are optional, and you can add as many as you need. Also, you can define keywords, so it's more easy for you to actually find them. when you're using them, which is just helping you down the road later. And also events can do something called replication, which is for multiplayer synchronization. And that's a more advanced topic we don't cover in this learning nugget. We don't do anything multiplayer today. Let me show you how to create a custom event. I can just do it in the same event graph. So I could just go over here, right click, and then I get a new context panel, and I can type in add custom event, hit enter, and I can name this to whatever I need. So this would be, for example, showcase event, enter, there we go. And I've just created a custom event, which I can design to anything I need. So I can add inputs, I could add keywords, and I can call this later, like I said, like a starting point or trigger at a later point in time. Something that even blueprint experts who didn't who already did a lot of work with blueprints rarely know about are parent calls. Because as I said, one of these things on video tutorials on YouTube that will not tell you about that. So parent calls actually are available to any pre-existing event. And any pre-existing event needs to care on how to handle the parent or base event. You can go to them and right-click Add Call to Parent Function to add them in. Your options for handling these parent calls are overriding them. You just ignore. So whatever was in the parent class, you're replacing it with your custom logic, meaning it is gone. Whatever was defined in the parent class is gone. Or you can extend it. That means you're still keeping the parent class's logic and you're adding new logic to that. This is something, as I said, that even some professional blueprinters I encountered didn't know about. So why do you care? Also, you can define when the parent node is called. So that's also post custom logic or pre-custom logic. So why do you need to care about this? The reason is simple. Let me give you an example. You remember that sample I just did with the inheritance? Imagine you're having a car, and in the car's tick logic, it is doing movement logic like acceleration and braking in that tick. Of course, car also is based on other classes and so on. We don't care about that for the moment. We just care about this small snippet we have in our diagram over here. Now imagine you are inheriting down a subclass of car, in this example called your car, and in that tick logic, you do your custom tick logic. Now, if you override existing logic, the movement logic from the base class car, acceleration, braking, whatever you are doing in that tick, would never happen again. It would be overridden. So you're basing your car on the base car, still your car can't move anymore because it's not calling that. But if you go with your with a parent call, so you're extending the base car is still doing its movement logic from the base car's tick. So if you override it, you lose the logic from the parent. That's why you always should care about a parent call. Maybe you don't need the logic coming from the base element. That's fine. Then override it, don't go with it. But most likely you want to go and extend And this is something that I'm shocked that all of these YouTube videos and Udemy courses and so on, they don't tell you about, because this is basics. I mean, we didn't even talk about variables or something, and I'm already telling you this is absolute basics, and nobody talks about it. So that's why I'm here. You've got me. So let me show you about parent calls. Whatever I'm having over here, my event graph, got tick, begin play, my custom one, that one has not really come with a parent call, so I don't go with that. But these other ones, I can right click and I can add a call to parent function. That will add in another node looking like this. And now I can decide if I want to put my custom logic over here. So first I'm doing my custom logic, and then I'm going with my base classes logic. This would be a pre logic. Or I can put a post logic. So first I'm going with my begin play of the parent, and then I'm adding in custom logic. So it's just about where I'm putting this. And this should be done for any of these pre-existing events. If you don't do this, maybe you forgot it, you're overriding. And with overriding, you will run into very weird behavior, like your car isn't moving anymore, even though your base car has got all the logic. You have overridden it without knowing it. So you need to be aware of that. The next thing we need to talk about are variables. Variables are named data storages. The name is how we refer to the data storage. So the name basically is irrelevant after us working on the project. So in the end, it has got an internal name and an ID that is not public to us, but the name is just for us as developers, a label, you could say. And the type. So any variable needs to have a type, because we need to define what kind of data is stored inside. To add a variable, there is a little plus variable button in our blueprint, and that gives us a new variable that we can name, we can assign a type to it, and we have got some other nice properties and details we can change here. Variables are stored individually per object. So even if I define it in a class template, each object instance is having its own set of variables, all of the same layout. So let's say zombie A and zombie B, they're both objects of the class zombie. Still, whatever I define in zombie is available to any individual zombie out in the field, stored individually per object. We also have got instance editable, this checkbox over here, and that means that I can easily access and modify this variable from the editor, and again per instance. So to come back to that zombie example, the health points of each individual zombie I can access and even change them from the editor if I like. There's also this topic of replication. Again, that's multiplayer relevant. We will not cover replication in this Learning Nugget today. And we can assign a default value, which is the initial value stored in the variable from the beginning. It's always down here after that. So over here, underneath the variable, we have got the default value. Of course, what I can do with the default value depends on the assigned data type. Every data type has got different data stored inside. Here's a nice overview of the most basic data types that you're going to use in Unreal Engine. There are way more than that when we talk about object references and class references, and then there's also soft object and soft class references. Then there's also enumerations and structures. You see, this is so a big topic let's just stick with the basics here. These are most likely the basic data types that you're going to use. So Boolean is a 1-bit variable, true or false. Byte is an 8-bit whole number between 0 and 255. Integer refers to an integer 32, meaning a 32-bit integer whole number, going from minus a lot to positive a lot. Then there's also integer 64, which is referring to a 64-bit integer, and it goes from minus a whole lot more. I don't even know how to say this number, up to, yeah, a big number. Float, this is for floating point numbers, meaning comma separated values. So you've got a comma in there. Then there's name, string, and text. And this can, for beginners, be confusing. What's the difference between, because name, string, and text are all three holding a series of characters, meaning sentences, words, stuff like that. So what's the difference? A name is a text or a string in that case with no spaces or special letters. It's only encoded in UTF-8. So it's only having some basic characters, no special letters, no foreign symbols, and it should not be manipulated at runtime. You set up a name, you give a name to something, and then it stays on that name. You're not changing names. So a name should not be modified. Completely the opposite is the string, as the string is meant to be very manipulatable. So you can change a lot about it. You can basically take a string and cut it and trim it and add something to it. A string is any text of any length. It's also UTF-32 encoded, meaning you can add Chinese symbols, Japanese symbols, Cyrillic symbols, special letters, emojis, and stuff like that. So string in Unreal Engine is a very powerful data type. However, string is not meant to be displayed at any time to the user. As for displaying stuff to the user, there is text. Text acts as a wrapper for strings, so they are localizable. Imagine you have your application running in English and you want it to say hello world. But the same application now running in French should say bonjour, and in German, hallo, and in Spanish, something else. I don't speak Spanish, sorry. So you get the point. Hola. Very good. So a text just is a wrapper for multiple strings for different languages. And as Unreal Engine by its design is meant to be something for multi-language development, you use text whenever you are displaying something to the user so that you can have different values for different languages. Then there also is vector, rotator, and transform. And these three, they are something called a structure, or struct short. They are basically data packages where you bundle together multiple data types into a single new one. Vector, for example, is one of these data packages of 3 of these floating point numbers called float. So there's an X, Y, and Z data type in there, bundled together into something new called vector. The same goes for rotator with pitch, yaw, and roll. And then there's transform, having another vector location, a rotator rotation, and another vector scale. That in the end is a transform data type consisting of other structures, consisting of other data types bundled together. As I said, these are only the very basic ones, and there are much more than this. So let me show you how to create a variable. In my level blueprint over here on the left side, I've got a category or a part over here called variables. When I hit the plus variable button, a new variable is created, and I can call this whatever I like. I will just go with showcase variable for this learning nugget. Over here, when I have this selected on the right side, I have got the name. I can change it from over here or over there if I want to adjust the name. I can adjust the variable type, so I can assign a different one. I can say I want to go with a byte, float, string, text, all of these that we just talked about. And down here we have even more. There's even a search bar, so I can search for something in here and find what I'm looking for. I'm, for this showcase, just going with string for the moment. And as you see down here, the initial value, we cannot set it up yet. So to set the default value, we need to first compile the blueprint. Compile a script is not really what you would compile a program like. It's more like checking it for errors and applying changes in its setup. In this case, I want to go and say compile on the top left. There we go. And now the change in data type is applied, and I can actually assign an initial value called default value. In this case, I'm going with hello world, exclamation mark. So this is our showcase variable, called showcase variable for us as developers, but internally showcase variable is just holding a value of hello world of that series of letters. How can I now use that variable? For using variables, I can either use getters to read them. So I want to get the value. I don't want to get the showcase variable label or something. I want to read its value, hello world, exclamation mark. And the opposite is a setter, where for a setter, I can override the value. So I can give it a new value instead. So for setters, I need to define the order in which my code is happening. And I'm doing that for all kinds of nodes in Unreal Engine and blueprints with incoming execution pins and outgoing execution pins. On the left side, I've got an input parameter with the new value. And on the right side, there's an additional getter, like this one over here, for comfort reasons, because a lot of times you're setting a variable and the next thing you want to do is you want to access it and do something with it. So because that is happening that often, there's a comfort getter built into the setter in blueprints because it's more easy. So let me show you how to do that. Now that we've got the showcase variable, I want to actually use it over here in my blueprint graph. For that, I just use drag and drop on that showcase variable, and I drop it over here into my blueprint graph. Then a new little panel opens up, and it's asking me if I want to get, read, or set, override that variable. I want to read it for the moment, so I'm going with get showcase variable, and I've got a new getter node, which I can move around. And there's something really nice about variables in Unreal Engine. Color coding. Color coding data types means that we, even by just looking at this getter, looking at a setter, looking at an input pin or output pin, looking at a connection, we know what data type is stored and processed in there. In this case, without even looking, just by working with blueprints a bit, you know a purple getter or a purple variable is a string. As for a red one is a Boolean, a green one is a byte, a light green one is an integer, a green one is a float. This is also green, or green here, green's over here. Purple string, yellow vector, orange transform, and so on. So it's just really easy for you to recognize what data type is in this case the case. Besides variables, as a basic thing about blueprinting, we also need to talk about functions. Functions are smart code snippets that are isolated and reusable. These functions can be created in our blueprints, and they can have inputs and output parameters, as many as we need. Input parameters is something that we put into our function the moment we are doing it, we want to execute it, and outputs are return values. This could be something like I put a plus b into my function, and I'm getting the result of that formula or mathematics out on the other side. It really depends on what kind of function you're programming there, but in the end, you always get a return value on an output. Also, for functions, we've got something called access specifiers. The access specifier says from where is the function accessible. Is it accessible also from the outside or just from the inside of a blueprint? We talk more about that later, so don't worry about that very vague description. Then there's also keywords. Again, they are just there to make it easier for us to search for something. So we can type in keywords over here. And there's also that compact node title. With that, I can compress my node to be on the visual side a bit smaller, having taking up less space, being maybe even more easy to work with, easy to read. Really depends on what we're doing. And also what functions can do, they can do local variables. These variables are only initialized, accessible, and storing data as long as the function call is going on. As soon as the function is over, it has returned something, it is finished, that local variable is gone. So it is a temporary local variable. You may be confused right now. Functions, aren't these just the same as events? As where events are these triggering points, I can call them, I can start them, and functions I basically just described the same. They have similarities, but you need to decide if you want to go with a function or event every time you're programming something. So let me help you to understand the difference. You want to choose a function if you expect return values. So you want to give something into it, and you expect to get something out of it. As I said, a plus b equals result, something where you expect a return value of in any case, you want to go with a function. Also, you want to choose a function if the snippet should be executed immediately. So there's no latency, there's no delay, there's no latent nodes or anything like that. Then you want to go with a function. And also you want to go with a function if you are fine with the function not being automatically optimized for you. Keyword there is multi-threading. Functions are always executed in the main thread occupied by the Unreal Engine's application. So maybe you know about this. Your PC is having multiple threads, multiple cores running at the same time. And on one of these, mostly core 0, let's call it like that for the moment, your application is running. Now, what modern software can do is they can distribute the workload across all of these multiple threads, multiple cores that you have in your machines. And functions are not automatically distributed across these multiple threads. They will always happen in the core 0 thing I just mentioned. That's also why they can't be doing anything like latencies and delays. You want to choose an event, however, if you don't need to retrieve any return values. So you don't expect anything back. You just want to say, do that, and you're not expecting anything in return, a trigger. You want to use latent nodes like some asynchronous nodes, async nodes, delay, or some other latent nodes that there are in Unreal Engine. And you want to utilize automatic optimization because events are distributed across all available threads and cores in your hardware. Automatically, you don't need to do anything for that. So the conclusion for using a function or an event is that you most often want to use an event and only go with a function if one of these things up there is true. So how can you actually use these functions? Using these functions would be calling a function, meaning executing it. For that, you execute a function or event by calling it. A function call is looking like this. It's a blue note stating on top what function is being called. It's also having a target, so for who it is doing that, and also for what kind of object. It's having an incoming execution pin and outgoing execution pin, similar to the setter we just saw. And optionally, there are also parameters, input parameters and output parameters as well. That is a function call. Let me show you. We were just having this getter for showcase variable. I now want to do a function call on some function that Unreal Engine already is providing to us. With Unreal Engine, you don't need to reinvent everything. It is already filled up to the top with already existing functionalities that you can just use. For example, I want to see this hello world on my screen the moment I have the life cycle of my world begin. So on begin play. For that, I do a function call on something called print string. String, that's the data type over here. Print, that means debug printed on the screen in the top left side. To do the function call, I right click in here and I just type in print string and I get that print string node. This is a function call. I attach it to my begin play over here and it's accepting an input parameter, the string it should show. And this is where our variable getter comes into play. We just want to connect this up. So it's now the moment doing print string, reading the variable hello world, hit compile, save. I'm going back to my level. I hit this play button up here because at the moment, this level blueprint is not doing its thing. Begin play is only executed the moment the life cycle of that script, of that actor starts happening. So I hit play, and on the top left, I see hello world written in blue color for 2 seconds. Hello world, there it is. Why is it just for 2 seconds and why is it blue? The reason for that is that I can open up the print string advanced panel down here, and there are way more inputs. So I can say I don't want this for 2 seconds, but for 30 seconds. And I want to change the text color from blue to some other color, which maybe is more easily to read on the blue sky anyway. So I've now changed it to hello world in orange for 30 seconds. And that's what input parameters are for. They are changing the way a function is happening. They are changing the behavior of, in this case, print string. And this could be any function that you're calling. Besides these functions that we just went through, there also are pure functions. Pure functions are functions that are called in reverse, meaning they are called the moment their return value is needed. They do look like this. They have a green node, no execution pins. This is important. And you see, they always should have an output parameter because they're only called in the very moment this on the top right side function call is doing something, looking at its input parameter, seeing, oh, the input parameter is connected to something. It's a pure function. OK, and we execute the pure function to get our result to forward it back to our function call up there. That's why it's called in reverse. A pure function without output parameters can never be called. Wouldn't make any sense at all. To create one of these pure functions, we can, of course, create at any time a function. And for that function, at the moment, it would just be a regular function like this. But when I have this function selected and I say, I want this to be a pure function, I just click on it and it becomes a pure function. And depending on the inputs and outputs that I have set up, it will also have them as pure function. And whatever I'm programming inside, so I'm double clicking the function, it's opening up a new blueprint graph for me. This is inside of our function now. I can define what this function should be doing and then just call all of that complex logic from one node, making it really easy for us to keep on working and extending our code. In the next step, I want to show you a proper interaction between a light switch and lamps based on the third-person template. So I actually want to show you a bigger demonstration, more than just these small snippets, and show you how you can work with blueprints to achieve that. For that, I can close down my level blueprint as I'm not interested in that anymore. So the goal we want to go for is that in our level, there's a light switch and a few lamps, and going to the light switch, interacting with it maybe in some way, we want to be able to activate the lamps and deactivate the lamps. So how could we do that? First, let's take a look at what we currently have. The moment I hit play, I'm getting this third-person template. It's Quinn from the template, this robot girl, and we can move her around using our keyboard and mouse. We can jump. And the next thing we need to do is we need to set up a light switch and some lamps. And then when we have that set up, we want to tell this character Quinn that hitting a certain key on our keyboard interacts with that light switch. A more complex thing than just printing string on the top left side, but we will go through this. Let's take a look. So far, everything that we've done was in the level blueprint. The level blueprint is fine and nice and so on, but what we want to go with are blueprint classes. And I can create a new blueprint class down here in the content drawer. Creating a blueprint class allows me to create meaningful, reusable objects or templates of objects that I can use over and over and over again in my project. I'm creating a new folder down here, and I'm calling that one Learning Nugget. In that Learning Nugget folder I just created, I want to go right-click and go for Blueprint Class, as we want to create a Blueprint class. By clicking on that, a new panel is opening up. As I just explained a few minutes ago, we are always going for blueprints in Unreal Engine. We're always going for parent class inheritance. So we need to pick from what parent class do we want to inherit this new object, this new template, this new class that we are creating. And the most basic element in the Unreal Engine that we can just place in the scene is actor. It is just holding components of any kind or blueprint logic of any kind. It's just very basic object in Unreal Engine, actor. So I'm going for that one. And I'm calling this one now light switch, as this is supposed to be our light switch element that we can interact with later. And when I'm creating light switch, I also want to create that second element before actually going into it and programming and setting it up in some way. I want to also right-click Blueprint class, actor, create lamp as the second object. So we have got light switch and lamp, and we can have multiple lamps in the scene, and they're all controlled by a light switch. That's the way light switches work. So when I have the lamp, I'm double clicking on the lamp, and a new Blueprint class editor is opening up for us. As always, I'm dragging it by its top, so it goes up there to the top control. This is the lamp, and a lamp is supposed to have some kind of a visual representation. In our case, a lamp. So I go with a static mesh by adding a component to it. On the top left side, for this template of an object that we have over here, I want to add in a static mesh. I call it lamp mesh. Currently, the lamp mesh is empty because we didn't assign a static mesh yet. As I'm using the starter content of Unreal Engine, I'm having some basic elements from the starter content, and I'm going with the lamp ceiling for the moment. So as you can see, I'm now having the lamp over here. Nice. But that just is the lamp itself. I also want this lamp to have a light source. So I'm adding another component to this, and I'm going with a spotlight. The spotlight currently is placed wrong and looking in the wrong direction as well. No problem. I can just move it down here to where the light bulb is. And I can make it face downwards as well. And I can also change its outer cone angle. So it's actually by 80 degrees, it's fitting in here. That's nice. So this is a Blueprint class. We have set up some components, the way they should be rotated, some properties of them, some of these light values, some of these static mesh values, and so on. But this is just setting up a Blueprint class. This is not blueprinting itself. Where can we do our blueprints? No worries. We also, in a Blueprint class, have got that My Blueprint panel. And when you go for Event Graph, it's opening up the Blueprint graph again. This, in this case, is not a level blueprint. This is the Blueprint graph of lamp. So whatever we are programming in here will happen for each instance object of lamp. One of the things that I want to do is I want to prepare 3 events for this lamp, turning it on, turning it off, and toggling that, basically cycling between off and on. We already have got our event graph over here, and that's nice and all, but a common bad practice that a lot of programmers are doing in blueprints is writing all of their events into the event graph. That is not the way the event graph was supposed to be used, even though everybody is doing it this way. But I want you to be better than that. I want you to understand that you can actually create as many graphs over here as you like. So I'm creating for this a nice and fresh lamp graph. This lamp graph is now supposed to hold all the events relevant to handling this lamp. So we don't fill up our event graph over here. Having a good structure in your blueprint graphs is key in your future work with blueprints, because you don't want to end up with blueprint spaghetti. So lamp graph in here, I want to create 3 custom events. Right click, add custom event, and I want to call the first one turn on. So what is turn on of a lamp supposed to do? We take our spotlight, and actually that's a nice thing of blueprint classes. You can use components, these guys over here, in your blueprint graph like variables. So you just bring them over with a drag and drop operation. You get a getter on the variable. There's our spotlight. And I want to set the visibility of that to be on. Now I did there something without explaining it because I'm just so used to this stuff. I'm sorry for that. So what did I do? I dragged from the spotlight and let go. I did not just right click. I dragged from that spotlight. The reason for that is context sensitivity. This is something that can be enabled and disabled up here on the top right side. And what is this for? You see, when I'm just right clicking, it is giving me a selection of actions, of nodes that I can actually do for lamp, this blueprint class. All of these actions. If I turn this off, I get all possible actions Unreal Engine Blueprint can do right now. But if I go from the spotlight, I get different actions because I'm now getting actions that are compatible with a spotlight component. And set visibility is one of these nodes that target scene component can happen on that component. If I'm just going over here with set visibility, I may get different prompts. That's why context sensitivity always is to be used. Drag from what you want to interact with. I want to set the visibility on turn on to be enabled. I'm adding a second event, turn off. For that, I want to copy by copy and paste, Control C, Control V. Now, how did I do that? These are nodes. How can you copy and paste nodes? That's interesting. How is this happening? Actually, in the end, what you're seeing over here just is a visual representation of code. So if I were to open up a notepad, and in that notepad, I'm now just pasting in, you see this is actually what this is storing. Of course, this is much more nice to work with, much more easy to recognize, but this is what is actually holding there. And you see what there's also saying? K2, Kismet 2. That's just the internal name for Blueprint. That also, little trivia on the side, is allowing us to put this on an external tool that's called Blueprint UE. So I can put my blueprint in here. Yeah, that's fine. 1 hour. Don't want to have this in there. And I just have created a paste bin with my blueprint logic that I could easily share with others on forums, in Discord, and so on, to ask them on my snippet of blueprint code for help. Because you don't want to send them screenshots or something of your blueprint graphs. At some point, your blueprint graphs, you need to scroll out, zoom out. You don't see anything in there anymore. So you just paste them on a paste bin like Blueprint UE, and you can share this with others. So this makes a lot more sense. There you have the website. Yeah, you can also put in a text file, but that would even be more hard to work with. Oh, and now I get it. You don't want to do it with a text file. Now I get it. So on turn off, I want to disable the visibility. And then I want to have a third option, toggle, which in our case should just go with toggle visibility, which already is a pre-existing function that we can use on spotlights or scene components in general. And with that, in our lamp graph, we now have got turn on, turn off, and toggle, which are the three most basic things a lamp can do. Great. Now I want to place some of these guys in our scene. This is our template, classes equals template. I know, I think by now you should have understand that analogy. So I'm just putting a few of these guys into my level. Just copy and paste some of these over here. There we go. So now I've got some lamps. And all three of them share the same class. So if I were to change that class, for example,
Some kind is broken.
do you hear me again?
Yeah.
Great. It's always like that with classrooms that are not responding to me because after half an hour this headset turns off when I get no input. Maybe I should play back a little bit of music in the background or something. So what I wanted to say is if I'm now adjusting this template, you see at real time, all of the instances are changed along. So whatever I'm doing there, it is automatically happening to all instances. Now that I have my lamps, I also want to create a light switch. So I'm heading into light switch. I'm adding, unfortunately, I don't really have a static mesh for that, so I'm just going with a cube. So this is our cube. A 1 meter by 1 meter by 1 meter cube, way too big for this. So I just go with a 10 centimeter one by scaling it down. And I want this light switch to be able to control these lamps. So how can I do that? For that, I need to have a variable referencing a lamp, not a data type, not an integer or float or string. I want to create a reference. This is something new. So I'm going with a variable and I'm calling this one lamp. And when I now go in here and I search for lamp, actually, there are also object types down here. And I can go with a lamp object reference. So I want to reference an individual lamp in the scene. I hit compile, save, go into my scene. I'm placing my light switch over here on the wall. Nice, there it is. But there's no way right now for me to set up that this light switch should be in control of these lamps. The reason is instance editable. I forgot to put this lamp to be instance editable because only when I'm doing that, click checkbox, compile, go back here. Over here on the right side, when I have the light switch selected, I can actually see the lamp as a reference. There's a picker, there's a drop down. I can go with a drop down, but I can also pick them from the scene. Unfortunately, at the moment, I can only select one of these. But wait a moment, I want to have all of them. So for that, we can do something to variables over there where the variable type is assigned. Right of that, I can choose if I want to go with a single variable, a single lamp, a single integer, a single Boolean, and so on, or with an array, a list, multiple, a list of multiple lamps. And then there's also set and map, which for the moment I don't cover. So I'm going with array, a list of lamps. Hit compile again. Every time we're changing something about our blueprint, our components, our data types, we need to go with compile. And now I actually have over here a list, an array, where I can assign multiple lamps to this. So this light switch is now aware of all of these lamps. Great. Now I want to program a kind of interaction with the light switch. Just like before, I don't want to clock up the event graph. I'm creating a second graph because we can create as many graphs as we like. Why go with always event graph? It's just a bad practice. Don't do that. So in this case, I'm creating a light switch graph. And in the light switch graph, again, I'm going with add custom event, and I'm naming that one interact with light switch. And what does interact with light switch do? Easy. We want to get the lamps, all of them. We don't know if it's 1, 0, or 100 lamps. In all cases, we want to go with every lamp that we know about, and we want to toggle it. So for that, we're getting our array of lamps. An array is always looking like this with these multiple squares. And there is something in scripting and programming called loops. Loops are handling multiple elements, iterating through them. There are for loops where I can just define a number of iterations, while loops, while a certain condition is true, this should go on. And in this specific case, what we are going to do is a for each loop. For each lamp in this array, we want to do something. So for each is just a kind of loop available to us. And it has an incoming execution pin and a loop body. This is happening every iteration for every entry in the list. And in the end, when it's done, it's going on with completed. So for every iteration, we now have got a single element of lamp where we can say we want to toggle that lamp. And this is the function call to our event that we created. Actually, I can double click on this and it's opening up the lamp and highlighting the toggle. So wherever I am, double click will bring us over to the other event that I'm calling. Great. So now interact with light switch will go through all the lamps and do the toggle. But at the moment, there's no way for us to actually do the interaction. The setup of light switches and lamps is fine, but I don't know how to interact with this. And for that, we need to take a look at inputs. The input system in Unreal Engine 5.1 changed massively. The new system is called Enhanced Input System. Up to Unreal Engine 5.1, there was another system in place. It was fine, it was good, it did the job for the past 10 years. But Enhanced Input is having a lot of improvements and more state-of-the-art workflows, basically having our current needs in mind. So that's why Epic Games did the step to even say we don't support the old system anymore. Everything is from 5.1 onwards now fully on the enhanced input system. It's a built-in plugin which is always active. You don't need to do something on your own there on something specific. It's just in there. Just have it active, which is per default the case. And the new system is working with two kinds of elements. Input actions, which are assets in our content drawer. Each asset, each action individually defining a single input action a player can do, like interaction or looking around, moving, jumping. And then we have got an input mapping context, which is referencing these actions and mapping them to action mapping these inputs to player actions, looking like this in the third person template. So we need to create a new input action for interaction. I'm going to the content drawer, and in the Learning Nugget, I'm right-clicking, input, and I'm setting up a new input action IA underscore interaction. And when I'm opening this up, I see I can do a few things in here. For the moment, the thing that interests us the most is the value type, which is a Boolean. That's fine. It means I can press and release 1 or 0, true or false. But there also would be other kinds of inputs. For the moment, I'm just interested in that one. And I want to add this IA interaction now on that input mapping, which already is in our project in the third person input IMC, input mapping context default. I open this one up, and there's jump, move, look, and I'm adding a new one for my interaction, and I can now map it to a key, for example, to F on my keyboard. Great. Now IA interaction will happen as long as my character and player is using that input mapping context, which is the case in this template, and I can now use it. Great. Still, I have not programmed anything about interacting with the slide switch. I just laid the groundwork for this to be possible soon. I'm opening up the BP third person character, which is Quinn, that we can control over there in the scene. In there, we have this input mapping context already added to the player. So we don't need to care about that for the moment. And we can just go down here and say, I want to go with our IA interaction event. There we have our event, and it is already available to us. I can show you by print string hello, totally fine. So if I'm now running through the scene, every time I hit F, there is hello. That means it's already working. Cool. So I don't want to spam hello over here. I want to interact with the light switch. How can I do that? I want to, in this case, not do any complex work like, is this light switch in front of us? Can we actually interact with it? I just want to get the first best actor from the scene, because that's a lot more easy for us to do right now. And we just go with it this way because of time reasons. So I type get actor of class, which will give me the first available actor of that class from our scene. I want to get the light switch. And what could be the case is that there is no light switch in this scene. So something that in Blueprint we still always need to make sure of is that we actually have something to work with. We do that by going with is valid. Is there actually a valid object to go with? Otherwise, we could run into a lot of warning messages in our output log, and everything is spamming error, 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 because we are trying to utilize objects that we can't reach right now. So is valid is a really helpful thing against that. And what I want to do is I want to interact with the light switch if this is valid is true. So if this is valid. Now I've got this, a little bit ugly kind of situation that my connection over here is going through the is valid node. That can happen, but it's triggering my OCD. So what I want to do is I want to double click on the connection and move it down here so it can actually nicely go around the other node, and there are no intersections. And also, this is not just For personal preference, this is also better readable. Imagine you having 100 connections there. Having them neatly organized definitely helps understanding your blueprints. So if I'm now going around the scene, hitting the F key, my interaction is actually working. Hooray! Our first input and blueprint having a meaningful inter-blueprint communication just worked. And so will yours when you also do these steps after the learning nugget, when you have learned this. Great. But I want to show you even more. So the next thing I want to talk about are event dispatchers. Because right now, the light switch needs to reference all the lamps. And if there are now more lamps added, I would need to go back into my light switch and would add the lamp to it. So that's a lot of work. I want to have it more flexible. For that, event dispatchers can help. Event dispatchers are registries for event binding. So I can bind events to these event dispatchers, and they can be called, so executed, on all the bound events. Event dispatchers are created per instance. So if I, for example, have got several light switches in the scene, all of them have their own event dispatchers. There's no central event dispatcher, but every object has got its own. Like variables and functions, they all have their own event dispatchers. Event dispatchers in the naming should start with on, so on light switch interaction or on something cool happened. I can call them, I can bind and unbind specific events, and I can also say unbind all, basically removing any event that was bound to it. And I can create an event or assign an event to an event dispatcher. Looking like this is a bind event. So I've created a new event and I bind this to the on something cool happened event dispatcher. But this can, when you work with this a lot, really, clog up your blueprint graphs. So it's really hard to read them. For that, I recommend going with the create event node to keep your graph clean for assigning a function or even remote events on remote objects. So let me show you this in our sample. Over here in our learning nugget, there is the light switch. And on the light switch, I want to add a new event dispatcher, which is this over here on the bottom left. There you see event dispatchers. And I click on it and I say on light switch interacted. This is now a new event dispatcher that we have set up. I can give this event dispatcher input parameters. I can change the way it behaves, but for the moment, I just want to keep it as it is. Now, what I can do is when interact with light switch is happening, I want to call this on light switch interacted by dragging and dropping and saying call on light switch interacted. We also can remove this logic from over here. As I said, this worked fine, but I don't need it anymore. So what we can do is we can remove it, okay? But we can also just move it away by unlinking. You can unlink by right-click, break this link, or holding down the Alt key left from the spacebar, left mouse button to disconnect them. So when I have disconnected them, I can just move them over. They will not be called anymore. If nothing is going in here, they will not be called. They can just live there. And I'm replacing it by the call on light switch interacted event dispatcher.
Show the control key moving some connectors.
Sorry?
Not to delete it, but to reconnect it. you can use a control key as well. This is a nice function to have.
So you mean the Control Z, Control Y?
No, the
Wait.
Steuerung.
Yeah.
Not the Alt key and the Steuerung.
Yeah.
Yes,
Okay.
it's
No, I
moving.
get it. Okay. I understand what you mean now. When you hold down Control while you're over this, you can actually move this over to another point, so you can reconnect them, like plugging them out and plugging them in somewhere else without disconnecting them first. All right. Thank you for that, Volker. Okay. So with the interact with light switch, call on light switch interacted, I don't need to reference all of these lamps. It's fine for the moment. Just leave it in here for the moment. But I actually want to now have my lamps hooking up their toggling logic to this. So what we do is we're going for our lamp, and at some point we need to find the light switch and bind toggle to that interaction event dispatcher. A good place to do this is begin play, where the life cycle starts for this lamp, each lamp individually. So I'm going for my event graph. I don't need these two over here, so I can just delete them. And as you just learned, we always should go with an add call to parent function. So we do this first, and we want to extend this event begin play, add our custom logic to it. So we want to get, by get actor of class, from the scene, the light switch. Again, it could be that there is none, so we need to watch out for this, only if this is valid. And on that, I want to bind event to on light switch interacted. So binding in this case means the moment that this is called someplace else, this event is called. And as I said, from over here, you can go with add custom event to create a new one, but this can easily, clog up your blueprint graph. So go with create event instead. And with create event, I can remotely call, for example, the toggle function, or turn off, turn on, or any other of these functions or events we have that is matching the event dispatcher's signature, meaning the same inputs and output parameters. So I go with toggle, and just like that, even if this light switch is not knowing these lamps anymore, I can still toggle them on and off. And I could have many more of these. So I could have them all over the place. And without going back to my light switch, I can still interact with all of them. Because they are just listening on that light switch for the event dispatcher. Another thing that I want to show you, unrelated to event dispatchers, of course, are macros. Macros are compacting multiple nodes into a single macro. So this is a sample I did earlier. I just came up with it. I don't know what it's for, but I just wanted to show something. So we've got A and B as inputs and do some operations with it. And then we've got a macro. It can also have multiple execution pins as inputs and outputs. So this is something that functions, for example, could not do. And you may ask yourself now, what's the difference to a function? A function is a standalone isolated code snippet, as where a macro is at runtime basically just replacing that macro call, this one over here, with its content. Of course, it's not doing that in your blueprint graph. You want to keep it nicely organized. But the difference is isolation, replacement. To be honest, after working several years with blueprints, they are rarely used. I don't use them often. There's not often a need to have them. But when that rare moment occurs where you want to have a macro, you now know that they are there, how to set them up. They're super easy to do. You just go over here to your light switch or lamp or wherever you want to go. There's macros and you can create them and you can assign inputs. And as I said, there's also execution pin as an input, which is not available in any of the other ones, and outputs. And you can do any kind of logic in between. And with that, you can create reusable snippets similar to functions, but by replacing, not by having standalone functions. Talking about standalone functions, I also want to introduce you to the concept of function libraries. Function libraries are for static functions, meaning that you put functions into a separate asset, like a library, and you can access them from anywhere in your project at any time, and they can even be pure. As they are static, they do not have a target object. They can be having inputs and outputs and all these kinds of things, and they are static. Here are some helpful extras. Some tips and tricks I want to introduce you to. You can select multiple nodes and hit the collapse function. So when you go to for example, over here to our place from earlier, this one, and I want to collapse them because this is now a big chunk of code later, you can just go in here and say right mouse, collapse nodes, and it is collapsing them to a collapse graph, also being listed up here looking like this, and you can go inside. They are similar to macros. So you can just call them from anywhere. What you can also do is you can collapse multiple nodes to a function, or you can collapse them to a macro. Collapse to function means it is just creating a new function for them. And collapse to macro, as the name says, is doing the same thing to create a new macro for you. Like this. And you can also expand a node to get the insights out into your blueprint graph. And for example, the for each loop also is a macro. So you could also expand this out. Take a look inside. This is the logic for a for and for each loop. You most likely don't want to do this right now. I just want to show you that you can actually do this. Also, something that I learned the hard way is there is a math node called mass expression. You don't need to set up all of your formulas and mathematics and I don't know what you're doing there. Stuff like that. You don't need to go step by step, blueprint node by blueprint node, and write this by hand. You can just go in here and add a mass expression and type into the name. I just come up with something. You know, over here, I see there's Volker. So I want to have a variable called Volker, and Volker plus Daniel times Robin. So what I now just got was a mathematical expression having the input Volker, Daniel, and Robin, having a return value, and this is what it automatically generated inside. And this was a very easy mathematical equation. This can be anything. Like go to any hard place you like, anything that is really, I don't know, go to some mathematics websites, copy a formula, paste it in here and it will work. I was really impressed on how good this works. And you don't need to create mathematics now by hand, because normally you would go in here, what inputs do I need, and plus and subtraction and multiply. Don't do that. Just go with one of these math expressions, way more easy for you. And also you can quickly change them and they're regenerated for you. So there's really no bad thing about math expressions. Also, you can align nodes through alignment. That means in here, for example, where we have something a bit more complex, like this, your nodes are all over the place. Oh no, spaghetti. What you can do is you can have a selection, right click, and go with alignment. So you could, for example, say, I want to straighten connections, and it's automatically straightening up the lines. And now you've got them all clustered up together. Right click, alignment, distribute horizontally. Great, this worked not so good. But normally this can help a bit. Now, when you remember not to go with alignment, but when you go with these keyboard shortcuts, by quickly knowing them, Q, and there you go, you have them all aligned well. So this makes it much more easy than to single-handedly trying to arrange them, spending minutes on that. You don't want to do that. You just want to hit Q or alignment, and there you go. Also, for any kind of programming, so this is not just blueprinting, use the documentation, use Google, don't be afraid to ask questions. Even after working multiple years now with blueprints and having programmed basically all of my life, I'm always having some documentation on one of my displays, on one of my monitors over here, because you need to know what to search for and some keywords. You don't need to know everything. You just need to be smart and need to find it. That's all. So what could be your next steps? You want more. Take a look at blueprint interfaces, giving you the ability to abstractify calls between blueprint classes. So your, for example, light switch doesn't even need to know what a lamp is anymore. It is just saying turn on, and it could be turning on a garage light, turning on a nice wall light, whatever kind of lamp you have. Abstractify, that's blueprint interfaces. You can also take a look at macro libraries. I just showed you function libraries. You can do the same for macros as well. You can also take a look at the Unreal Gameplay Framework, which is an essential part of working with blueprints in a meaningful way in Unreal Engine, but we will most likely cover this later in a separate Learning Nugget. Take a look at tick intervalling, meaning that you set the tick rate per actor. And also take a look at custom enumerations and structures in your content drawer. You can create them, you can work with them, take a look at them. So hit me with questions and I try to answer them over in the Discord channel. I see it's for the moment really silent over there. Daniel is already typing. So if you have any questions, let me know and I try my best to answer or directly showcase over here in the project. Daniel says that the nugget was good for him. Brain grow, that's good. No questions at the moment. That's a shame. Nothing I can help you with, but that's fine.
If I just make a suggestion, like the second half where you were going through your examples, if you had done that first, I think I would have preferred it, because I felt, look, it was a little bit dry at the start. You're just kind of listing off things that you knew we didn't understand, and then, you know, referring them later. So it would have been, I think, nicer just to kind of start just putting nodes in and say, look, this does this, this does this, and then building out the knowledge afterwards. I mean, I kind of struggled a little bit. So like for me, I'll probably watch the video and start with the second half and then kind of watch the first one again. If but other than that, yeah, it was cool. Thanks for the information and stuff like that. And deep tips are really good. You know, it's just one of those things that we'll probably have to come back to, and you know, once we've got a better idea.
Good to hear. And thanks for the feedback. Much appreciated. Maybe for the next time I will change the order. Makes sense. Thank you for that.
Awesome. Right. Well, I'm going to disappear then. Thank you very much. Ciao.
Right. Take care.
Wiedersehen.
Volker is wanting to toggle a sphere in the scene on and off. Okay. Let's take a look. So if I get you right, you want to have a sphere, which could also be these lamps, and you want to turn them on and off. So how could you do that via blueprint? For anything, like also your static meshes, you've got the set visibility. And you can set the visibility of any component on and off. So you could have your sphere, identify it, so which sphere in the scene you want to do this with, and set the visibility off and on. That's it. That's hiding and showing a sphere. But my button is in a editor utility widget. This is not something that we cover today. You can do it, Volker. That's no problem. Just go also with get actor of class or identify it with a tag. Get some way of finding from your editor utility widget that specific object in the scene, and you can go with that. So hope that helps. Jeremy says he was wondering when to use a function or an event. So let's go over that slide again. I have it somewhere over here. Let's just go back. Where was that? Where was that? I had it somewhere. Functions. There we have it. So when to go with an event and when to go with a function. Basically, you want to first think, can I do with an event, and try to do it with an event, and only if something requires you to have a return value. So something like did this work out successfully, Boolean return value, or an actual integer or float variable return value. Then you want to change it from an event to a function. But most likely, in most cases, you just want to start with an event and see if that works out for you, and only change this if you see an event not working the way you want this to be like. Jeremy, you can also write in the Discord if there's anything specific you want to ask about that, choosing between this. Jesse is asking, will there be more blueprint lessons that will go more in depth? Yes, we will do more. This was the first one. And before I go into all of these fancy things I want to do with you guys, I thought maybe first I need to tell you about the basics. So I'm totally aware that this is aimed for beginners, as I said. So maybe not everybody was here in the beginning, but I said that this is for beginners. But in the future, we will do more learning nuggets that are advanced blueprints, going more with the Unreal Gameplay Framework. What's a pawn? What's a character? How do they interact? Maybe even doing multiplayer. I already did a bit of VR, a VR learning nugget. So maybe we don't cover VR in detail in the future. But yeah, so we definitely will do more in-depth training on that. Dolet, you're asking for future nuggets, architecture questions. Okay, so that's an interesting one, Dolet. If you could please contact me in a direct message, me or Christian Steiner. We always take feedback like that, and maybe in a few months we do a learning nugget on architecture visualization. Would be cool. Of course. Fabian is also asking for more advanced stuff. I know this was just the beginning. This was just the first one of a multiple part series, you could say. Okay. I don't know the name, but just the username over there, and even that I don't even know how to pronounce it. But Ilbino. Sorry
You can
for
say
that.
Laurie, that's me.
Sorry, Laurie.
Yeah, Laurie, that's me.
Okay, all right. So you're asking for pure functions and why to use them, where to use them, what are the use cases. So that's actually super easy because even Unreal Engine itself is working with a lot of pure functions, of course. So let me show you, for example, get random integer in range. I want to get a random variable between 0 and 100. And oh, that's a pure function because it makes sense to be more easily connected up to some other thing. So for example, I want to, on begin play over here, I want to get a random integer between 0 and 100 and print it or use it somewhere, do something with it. So that would be one of the many different use cases to go as a pure function. Randomly generate a random generation, or calculations, mathematics, or get player controller. I want to get a player controller. This is Unreal Gameplay Framework. Maybe you don't really know what a player controller is, but we'll do that in another session. So get player controller. I'm getting the player controller from the Unreal Gameplay Framework, another pure function. So getters, calculations, and so on, they all tend to be pure functions.
Okay, so basically it's not connected to the flow, like it's not connecting to something before. It's computing something, has a return value, and then you connect it to the.
Yeah, so the workflow for this is when print string, in this case, the function call is happening, it is taking a look at all of these variables in the input parameters. And when it's taking a look at the input string, it sees, oh, I'm connected to this. And this is connected to this. And this is, oh, this is a pure function. And that is the moment the random integer pure function is called, is executed. It's doing the random value, giving this back. Then we have, I don't know, the random value 59. So 59 back to this, converted to a string. There we go. So it is going a cycle from the function call back to the pure function, back to the function call. That's a pure function called in reverse.
Okay, thank you.
I hope this helped understand this. If not, please tell me and I'll try it again.
Yes, it does. It does. It was really this reverse flow that I didn't got at first, but I think now it's way much clearer for me.
Okay, that's good. That's good. So here I can also show this again. It's called in reverse. So when the variable is returned, is got, it's actually calling this function and forwarding it back up there.
Thank you.
All right. More questions? Please hit me with questions in the Discord chat. Silence. Oh, well, if there are no questions, that's good for me. So as I said, your next steps, take a look at these things if you like, if you want more of this. And thanks a lot for your time. Hope you like this. This was the basics of blueprinting. So I'll stop the recording here. Now everybody's typing. Oh, I see some clapping hands. Thanks a lot. Thanks a lot.